So the first question I'm going to do was very sensibly suggested that I do one like it because it was one that last year the kids found quite tricky. So let's say that A, funny weird symbol B, equals A plus 2B plus 5. This is just a made up thing. So I've just made this new operation. For example, 3 times, oh no, I won't do that. I'll say, for example, I will actually, 3 times A is the same as A plus A plus A, okay? So that's, at some point somebody made up times because it meant you didn't have to add lots of times. It was precision of language, it was, mathematicians like to have a concise language, okay? So the question might say, what is 3 funny made up operation 2? And what we would say is 3 funny operation 2 equals, now I know that A equals 3, and I know that B equals 2, so my answer would be 3 plus 2 times 2 plus 5, so 3 plus 4 plus 5, so what's the answer? 12.
Like A plus 2B plus 5, is that always going to be?
Yeah, you get given that, okay? So let's make up another funny symbol thingy. So if we had A star B, let's decide that that's AB over 3A plus 2. We're just randomly deciding that. We're just saying, this is just a new operation, okay? So now find 3 star 2. We're going to say, we know that A equals 3 and B equals 2. So all you're doing is because A is there and B is there, and the stars, that's what stars saying. Okay? So, yeah. So this is going to be 3 times 2 over 3 times 3 plus 2. Notice your invisible brackets here. So we've got 6 over 11. Okay? Okay, so we're going to now try a different one. For example, if I was to go, what is negative 3? Negative 3 asterisk 5. That would be what? What's A equal? And B? 5. So what's going to be on the top? And on the bottom? Okay, order of operations. At the top we've got negative 15. Oh, thank you. And on the bottom we've got negative 9 plus 2, correct? And so we're going to have negative 15 over negative 7, which is the same as 15 upon 7. Okay? Good? Yeah. Excellent. Yeah. Alrighty. Now, the next, that's all you have to do. It's just substitution. What is that? Okay, one last one. I make up an operation. I'm going to go A asterisk B. Star B. And that's going to be AB plus 3 over B.
So do you make up that bit?
No, they give it to you.
They're given. You get given that, and they're saying, if this new made up thing is that, what is 3 new made up symbol-y thingy 2? So you decide, well, okay, A is 3 and b is 2. So it's just substitution. So you're going to go a times b plus 3 over 2.
3 times 2.
Oh, sorry, this one here is 2. So what have we got? 3 2s are 6, plus 3 is 9 upon 2. Okay? Makes sense? What if I've got 3 asterisk 2 equals 9 upon 2? How would I then find out, if I said 3 asterisk c equals 9 upon 2, how would I find out what c is? Okay, we already know what c is. What is c?
What is it?
Well, yeah, because that answer is the same as that, so it's actually 2. But let's say we didn't know that, okay? So we're given that 3 star 9. So we're trying to, yeah, hang on. Okay, so if you were asked something like that, what would you do? You would say, well, 3 star c equals 3c, correct? Yeah, plus 3 upon what? C. And what does that equal? 9 upon 2. Fantastic. So now we actually need to solve that. So how would I solve that? Well, first I want to get rid of the fractions, right? Does that make sense? Get rid of the fractions. So I'm going to go 2, 3c plus 3 equals 9c. What did I do there? I times both sides by c, or rather it was divided by c on one side, became times by c on the other. Check. And then with the 2, I times both sides by 2, or divide by 2 on one side became times by 2 on the other, and I had to do brackets. Yeah. Okay? It's a little bit like, it's like A, B, C, D, A, D equals B, C. These two equal those two. Yeah?
But, why don't, because we know that C is 2, why don't we just use 2?
Well, we really need to do this whole process. Let's expand that. What do we get? 6c plus, oh, thank you. Yeah, I need you. Is 9c. So 6c minus 9c equals minus 6, minus 3c equals minus 6, c equals 2. Or you could have seen here 6c plus 3c is 9c, so 3c must equal 6. Okay? Make sense? So c is 2.
I didn't see it like that, but because we know C is 2, I know. Yeah.
Okay. So does that make sense with the whole funny symbol-y thing? Okay, who's got the next question? Let's have a look at that. Factorising fully. That's partially factorised here, but it's not fully factorised. We need to see, can we factorise this? So what are two numbers? 5 4s are 20. So we have the 3. And then what have we got? We've got 5 4s are 20. The 5 and the 4, it's got to multiply to a negative number, so it's got to have 1 as plus and 1 as, yeah, we've got to have the plus 5 and the minus 4 to get this middle term here, and we've got the x.
In those situations, you told us that we had to, like, combine the two things together or whatever, and then make...
That's because this one here is a very easy one, because it's not really tricky with the coefficient. I'll show you by a different kind of a one. So for one that actually factorised to, let's say, 3x plus 1, and yes, 2x plus 2, yes, you need it in this exam. So here, expanding, you'd get 6x squared plus 6x plus 2x plus 2. So that's 6x squared plus 8x plus 2. I've given a very bad example. Show me what's common. This here is actually not fully factorised because that's actually 3x plus 1. What's common in here? A 2 and x plus 1. Okay? That's fully factorised. So if you were given this, how would you factorise it? First thing, you'd see there's something common to the whole lot. So you'd take that out, and 3x squared plus 4x plus 1. But you've still got a problem, haven't you? Because you've still got the 3 here. So that's when I go 3 times 1 is 3, and my middle term is 4, and I'm looking for something that adds to the 4 and multiplies to the 3. So 3 times 1 and 3 plus 1. And that's where I take my middle term 4x and I turn it into 3x plus x. Okay? So everything else stays the same. Do you see what happened there? That my 4x became 3x plus x. Well, you can't do it the other way because you've not finished.
So you have to in the easier questions you can just use the other technique and then when it's hard like that.
Yeah. So here, what's common to both here?
3x.
3x and what do I put here? X plus 1 plus 1 x plus 1. Did you see that?
Yeah, I get that.
And then you've got 2, 3x plus 1 x plus 1. So what happened there is this x plus 1 was common to both,
Yeah, so you can cross one out.
and the plus 1 went there and the 3x went there. So that's fully factorised. Okay?
Select this on noodles so I can look.
Okay.